Good morning all. I am Dr. Anagha Agrawal from Department of Public Health Dentistry, Nursing by Patel Dental College, Sakarchand Patel University. Today I will be taking your lecture on Introduction to Biostatistics. Now, being in healthcare professional, many of people ask me why biostatistics, why we need to learn the biostatistics, since we are dealing with the patients and we do not have anything related to maths and we do not like math. That's why we have entered into this profession. But maths is always there in every profession. Some or the other part of mathematics is this, and my aim here is to make you understand the maths part or the biostatistics parts to you in easy way. And the amount of biostatistics of the maths you need into your day-to-day practice is very less. So the first question that I have asked you is, why do you need biostatistics? So I'll just take you to a small area where you'll understand why do you need biostatistics, right? So can you see these numbers which are present on your board? So there are multiple numbers just randomly placed over there, and they're like, I can say, the clouds of numbers. So can you make any inference out of it? Can you make any understanding or any inference out of it? No, right? So as a biostatistician, now my work is to arrange these numbers into some pattern, some frequencies or some table to make you understand these numbers. Now can you see this table? So these are the same number which have been categorized and tabulated into a simple table which says that it is the frequency of marks recorded for the interns in some MCQ test. Now you can understand that there are no interns who have scored 10 out of 10. There are few interns who have even scored 0, right? This is the same data which was there on the previous slide. It was just tabulated and put into a proper manner. So this is the importance of biostatistics. What happens in research methodology, by the end of the research methodology, you gather all the data from all the community according to your survey. So you have numbers, those are like hundreds and thousands and lakhs of numbers, but those are just numbers which won't make any meaning to you, right? But to make a meaning out of those numbers, you need to learn biostatistics, okay? So I'll be discussing today's topic under these content. So first, what is statistics? It's an Italian word or a German word. So statistic is a measure of counted numbers or the information that you gathered through your research methodology. Now just a small history. Majorly the John Grant, who has considered as a father of your biostatistics, and then later on many people came like your Carl Pearson, then your Francis Edgeworth, who have removed so many statistical analysis and so many statistical formulas. You must be knowing Carl Pearson, the chi-square test, the most important, the most used and the abused test. So that was one of the statistical analysis given by Carl Pearson. Now I'll tell you what is the relationship between your research methodology, epidemiology and biostatistics, and why biostatistics or all these three are important. Now first is epidemiology. So epidemiology tells you about the disease and the risk factor responsible for that particular disease. So how much is the amount of disease, which are the risk factors related to it, how the risk factor is involved into happening of that particular disease. So until and unless you know the epidemiology about any disease, you cannot have any hypothesis to make a research out of it. So first step, that is epidemiology, is of utmost importance. You need to learn epidemiology to go for a research methodology. Second step is the research methodology, where you actually scientifically form a research based on the data that you previously have or a survey that you previously have, and you can remove some figures, some amount or some frequency of that disease in that particular community. Now, as I've already told you, that research methodology will give you only numbers. The numbers won't speak for themselves. Numbers do not have any language. So, to make your numbers speak, we need biostatistics. When these numbers are put into biostatistical formula, there will be some inferences out of those formula and your numbers will speak. So these all three things, they are interconnected, and any of this corner cannot be broken down, otherwise your result won't have any value. So now what is this? What does this show? This shows that there are facts which are present into your community, Okay, so these community facts which are there, which are scattered there, like what kind of facts, like what is the gender ratio of that community, which is the disease which is most prevalent, what are the risk factors present, how much is the education of that particular community, and how these all things they actually give their contribution towards the health of the community. Now these are facts which are there into the community. Now second thing is what we do with the help of research methodology, we gather these facts into numbers. For example, if we say the gender ratio is 992, so we've set it into number. So many adults are there, the CPI score or otherwise the income, average income of that particular community is 30,000. So we are just making figures. When we do research methodology, we gather these facts into figures. Now these figures are again put into statistical analysis to make any interpretation out of it. So again these figures will be giving you facts. So we collect the raw facts from the community, put it into figures, we put it into statistical analysis, and we have a refined fact about that community, saying that this particular risk factor may be the reason for that particular disease or high amount of disease in that particular community. Okay, so this was all about statistics. Now the main topic, that is the biostatistics. So we should go ahead with the biostatistics. So what exactly is biostatistics? Biostatistics is the study of human being or study of health sciences which is related to statistics. So when the part of statistics which is related to healthcare system, that is called as biostatistics. Now this biostatistics have two variants. That is, first it is the science of variation. So what does this mean now? So you can see in general in physics, when we say there are constants, there are constant. What does this mean? When we say the temperature is 1 degree or when we say the temperature is 2 degree, the exact difference between 1 and 2 is 1 degree, which is 1 degree of temperature, and we actually have exact 1 plus 1 is equal to 2 in physics, whereas in biological science this does not happen. We do not have constants here, we have variables here. So for example, if I say that a particular person is having 12 mm of Hg of hemoglobin in his blood, he is having normal hemoglobin, as well as the other person who is having 14 gram of hemoglobin in his blood, both are having hemoglobin in their blood and both are normal. So even 12 is normal, 14 is normal, 15 is normal, and in between values are normal. That's why we say that biological sciences are science of variations and there is no constant. We cannot say just only 12% of hemoglobin in blood is normal and more than 12% is excess, or less than 12% is definitely less amount of hemoglobin, but there is a range which is saying normal, that is 12 to 15 mm of Hg. Okay. Second is, it is the science of figures, where we actually gather the facts into figures. We've already discussed it so far. So what are the needs of this statistics is to define normalcy. What is normal? How much is normal? That means when I'm saying that the blood pressure in that particular person is 120 by 140 systolic is normal. So how do I know this normalcy? There are many previous scientists who have done some or the other experiments and they have found out that this is normalcy. But to define that, we need biostatistics. To test whether difference between two populations regarding a particular attribute is real or a chance occurrence. So if we compare two communities, whether whatever is difference, whatever is the amount of disease in both the populations, one will have more, one will have less. So whatever this difference is really there, but this is because of the error of the study. To find out this, we need some biostatistical analysis. Study the correlation and association between the two factors. If we are saying that this particular risk factor is responsible for that particular disease, right? This particular risk factor is responsible for that particular disease. Now whether whatever I am saying is right or wrong, to find out that, we need a biostatistics. Then to locate, define and measure the extent of that particular disease. How much of burden of disease is present in that particular community. to evaluate the public health program, vaccines and seras which have been given. Likewise, if we know that this particular community is susceptible for that particular disease, so in that case we give them some vaccines, some preventive programs. So whether whatever we are giving or whatever we are planning, whether that thing is going into proper manner, or whether that vaccine is actually working for that particular disease. To find out that also we need biostatistics. So there are various uses of biostatistics like this. Now we are actually coming to the topic, that is the biostatistics. Now there are three basic things that we need into our biostatistics. First is the population or unit under observation. So in your research it has been already decided which population you want to work for. For example, if I want to find out how much is the hemoglobin level of pregnant women, right? So my population will be pregnant women. So that is my population. Second thing is the set of characteristics or variables decided for that particular disease. Now the previous example, that is my pregnant women's, where I can decide the age of the woman, where I can decide the weight of the woman, where I can decide the particular trimester of that particular woman, whether it is in first trimester, second trimester or third. So these are the variables, whether that woman comes from a low socioeconomic strata or high socioeconomic strata, right? So these are the variables. How much is the education of the mother to be? So these are the area, these are the variables which have been pre-decided basically into that particular research. And third thing is the probability distribution. So previously all the researches have been done and they have some value which is saying that this is normal in that particular community, right? This much amount of disease happening into that particular community is a normal finding. So this probability value actually we are talking about. So this is normal for that particular area. So we'll come to know if there is much more disease than this probability value. We have to find out why this particular community is suffering from that particular disease, right? So these three factors. One is your population, whichever population you want to work on. Second is the variables of the population, and third is the probability value or the p value for particular disease into that particular community. These three things we need to have in hand, and only we go for statistics. So now we'll be going for the main topic. Before going to the main topic or before understanding statistics, we need to learn some new terminologies. Okay, without these terminologies you won't be understanding what statistics is all about. So very first is about population. We've already learned some part of it. So population is the entire group of people or study element things or measurements of which we have a particular time. So we need to find out certain facts about that community. So which is that community? That is called as population, the entire population. Okay, now this population can be divided into two, that is finite population or infinite population. Now what do you mean by finite? Finite means that is limited, right? Finite means that is limited. So if I want to do a study to find out the marks scored by final year BDS student in my subject in NPDCH, right? So I have a finite population of 94 students who are studying under me, right? So that is a finite population where I can reach each and every student, I can have score of each and every student and I can take them in consideration, right? So I need not have to go for sampling, but I can take the entire population into consideration. But there are some populations which are like infinite populations. Now what do you mean by infinite populations? So if I want to do a study on radiologist of Gujarat state, okay? So now there are multiple people staying in multiple areas of Gujarat and thousands of people will be there who are radiologists, right? So I have to go to each and every person and find out whatever I want to find out. I have to take some questionnaire with them, or if I have to assess them in any which way. Is it even feasible? Is it even feasible? So it is not at all feasible. The time is restraining, the resources are less, and the amount that I have to spend for this particular research is very much. That is absolutely not feasible. So what I'll do sampling. Now what do you mean by sampling? Sampling is a large proportion of individual items or units that has been taken up for actual study. For actual study, the study will be done on them, and ultimately that will be said that the entire population is having similar characteristics. So the sample should be exactly similar to your parent population. The sample should be exactly similar to your parent population. That means what? That means that the sample should be representative. Whatever age, gender formula is there into your population should be there into your sample. Whatever education level, socioeconomic status, occupation level, whatever demographic characteristics are there into your main population or the target population, that should be there into your sample. So your sample should be that, then only it can be said as representative, and this representative sample can be subjected into that research to have the results which can be said or which can be extrapolated to the entire population. Now this sampling we are using since ancient time. Like I'll give you an example from day-to-day life. So if we go to a grain store, if you're going to a grain store and if you want to buy 10 kgs of some grains, for example wheat, I've given example of wheat. So do you go to the grain store, do you pick up a grain of a wheat and then assess it and then put it on the weighing scale till it becomes 10 kg? Do you do that? Do you do that? Is it even feasible or possible for a person? No. Then what do? You just take handful of that particular grain, you assess the quality of the grain, and then you ask the shopkeeper to pack the 10 kg of grain from that particular batch because you are liking that batch. So this is sampling. When you are taking some handful of grain, that is the samples, you are assessing them, and you are saying if the handful of grain is good, then the entire batch is good, so I can extrapolate that result to the entire batch and I can take that grain, right? Another example I can give you, when you cook rice, okay, when you cook rice, do you go and check every grain of rice whether it is cooked or not? Is it possible? Is it possible? No, it is not possible. So what we'll do is, we'll just pick up some grains and we just match them and find out whether they are cooked or not, and on that basis, if those grains which we've removed are cooked, then we'll say that the entire batch of that rice is cooked. So these are the examples of sampling that we use in our day-to-day life, right? So how this biostatistics is related to day-to-day life, that I've also explained to you. So now the representativeness, that is the most important thing of the sample, and if you have a representative sample, then only your results are right, otherwise they are wrong. But in every situation, when we say that we are dealing with variables, we are not dealing with the constant, it is very difficult to have exact 100% representation of the sample towards the population. So this error also can be reduced with the help of statistics. Okay, so that is the one of the use of your statistics. Now another terminology, that is null hypothesis. Now before going to null hypothesis directly, I would tell you what is hypothesis. So what is hypothesis? Hypothesis is basically an assumption made by a researcher, which is a smart guess based on his educational right? So what is this guess? For example, if I am saying that fluoride, high amount of fluoride is leading to dental fluorosis. Okay, this is my assumption. High amount of dental fluoride in water leading to dental fluorosis or skeletal fluorosis. Okay, so this is my assumption. Now what statistics does is, actually statistics does not take this hypothesis into consideration, but statistics takes null hypothesis into consideration. Means what statistics does is, statistics do not prove that whatever you've thought is right, but it disapproves whatever you did not think. That means what? In day-to-day example, if I want to prove the all crows are black, okay, I want to prove all crows are black. So it is not possible me to catch hold of every crow and see and then report the findings. What I'll do else? What will, if this is my hypothesis, my null hypothesis will be negative or ulta of this, that will be one crow is white. If one crow is white, every crow is not black, right? So my hypothesis will be rejected. What statistics will do? Statistic will refute this null hypothesis. It will say there is no white crow. There is no white crow. So ultimately it has been proved that all crows are black. So statistics takes into consideration the null hypothesis and not the regular hypothesis, where your hypothesis is converted into a null or negative hypothesis, and it has been put into statistical analysis to say that whatever null hypothesis is saying, that is not present. That's why whatever the research hypothesis is saying, that is present. Okay, so that is for null hypothesis. Then next is the type 1, type 2 error. So see, since we are dealing with the variables, there is no such research which is error free. There is no such research which is absolutely error free. So what exactly happened? There are some errors which come because of the basic the demographic variations into the population, and second thing, the another error which comes into because of the design of the study. The designs of the study, they also have their own problems. So type 1 error is basically they come because of the variation in the population, and many of the time it is not possible to eliminate it completely. So we can consider at 5% of your error that has come into your particular research, and that's why we allow it to happen. So that is okay. That is okay. 5% is okay, but we cannot allow more than 5% of type 1 error, which is very important because this error holds your result towards very, if the error is more than 5%, then your result is absolutely erroneous. Okay, then comes type 2 error, where we can say that this is a little adjustable error. This is because of the design of the research, right? Design of the research. So the research design can be redo again, and we whatever biases or issues are there, that we can eliminate. That's why this is again a smaller error, but that's why we allow 20% of this kind of error into our research. Okay, so this is allowable for 20%, but not more than 20%, and type 1 error is for 5%, not more than 5%. Now we are saying variable. I've already told you what is variable. You can see that diagram, or you can see that picture, right? Can you see what are those? What are those? Those are the aprons, right? All are the aprons, but there are variation in the sizes of the apron. There are variations in the length of the apron, and there is variation in the basic color of the apron, but all are aprons. So this is variable, where it varies, but it fits into that particular name what we are giving it to it. So that is variable, and that comes into our biological sciences. And there are types of variables like dependent variable, independent variable, and confounding variable. Now what is dependent and independent variable? If we take the previous example, where we say that having much more amount of fluoride into drinking water may lead to fluorosis. Now the dental fluorosis or skeletal fluorosis. Now dental fluorosis or skeletal fluorosis, the occurrence of this depends upon the amount of water which is having more amount of fluoride, right? So dental fluorosis or skeletal fluorosis are dependent on the amount of fluoride which is present into drinking water. That's why the dental fluorosis or the disease which are taking into consideration, they are called as dependent variable, which are dependent on the risk factors like the amount of fluoride into drinking water, right? So this is the concept of dependent and independent variable. And there is another one, that is confounding factor. Now the confounding factor is actually associated with independent and dependent variable, and it can ruin both of them. For example, if I'll take another example where smoking is related to oral cancer, right? Smoking is related to oral cancer. So oral cancer here is a dependent factor, and smoking is independent factor. Now confounding factor, we can have alcoholism. So alcoholism have effect on smoking behavior of the patient, as well as alcoholism can be considered as another risk factor for oral cancer. So this can affect both the smoking behavior of the patient and the very occurrence of the disease. So this is called as confounding factor. Now the last terminology that I want you to go through, these were all the terminologies basically which we wanted to discuss, because without these terminology the entire biostatistics won't be any help. You won't be understanding what is going on. So I just wanted to know you about these terminology. So today, in today's lecture, we knew about the biostatistics, the statistics, the need of the biostatistics, as well as the various terminology that can be used. Right? For today, I am just winding up my lecture. Thank you.